Hey everyone, this is Meryl,
And this is Kritika.
And this is Abdul.
and we are Virginia Tech's electrical engineering students.
And this is an educational video made for the Design Empowered capstone, specifically for 4th through 5th grade elementary students to teach them about electricity.
You find all the slides and worksheets in the description. Enjoy!
Hey everyone, this is me, Meryl, and I'll be going over electromagnetics today. First, we want to talk about magnets. So what is a magnet? A magnet is an object or device that gives off an external magnetic field. What is magnetism? Magnetism is a force of nature which causes special kinds of objects to attract or repel each other. And as you can see in this picture, the Earth has its own inner magnet, which has its own magnetic fields. Now, here is a multiple choice question. Magnets can blank items. Can magnets A, attract, B, repel, or C, both A and B? Magnets can both attract and repel items. So the answer is C. Here's another one. Magnets have blank and blank poles. Is the answer A, good and bad poles, B, north and south poles, or C, red and blue poles? The answer is B, north and south poles. The Earth, like I said, has its own magnetic field, which has been used in many navigation systems, such as compasses. And as you can see on the picture on the right, each magnet has a north and a south pole, and the north and north are repelling each other. Now we want to talk about the poles specifically. There are two poles on a magnet. There is the north pole and the south pole. Now, what do you think happens when you put unlike poles of a magnet near each other? Just like the unlike charged ions in the static electricity presentation, when you put unlike poles of a magnet near each other, they should attract because they are unlike poles. And if you put like poles of a magnet near each other, the same type of poles like north and north or south with south, then they should repel with each other. As you can see on the right, there's a picture that demonstrates both of these concepts. On the left set of the magnets, there is the north pole attracting the south pole, and then on the right, the south and the south poles are repelling each other. So, if you have a south pole with a north pole, they attract. If you have a south with a south, they repel. If you have a north with a north, they repel as well. So what is an electromagnet? They are temporary magnets that only work when electricity goes through the wire. Let's do some fill in the blank. When the power is blank, it is magnetized, but when it is blank, it is not magnetized. What do you think the answer is? In this case, when the power is on, it is magnetized, but when the power is off, the electromagnet is not magnetized. Let's do a fill in the blank again with multiple choice answers. The magnetic field comes out of the blank side and enters into the blank side. Do you think it comes out of the south side and enters into the north side? Do you think it comes out of the north side and enters into the south side? Or do you think both A and B are right? In this case, answer B is correct. The magnetic field comes out of the North Pole and enters the South Pole. And as you can see in the picture on the right, this represents a magnet, and the lines, or well, the dotted lines, are the magnetic field lines. And even though most pictures do not depict the direction of the magnetic field lines, it is going from the north to the south. How do they work? Magnetic force in a magnet is always there. The magnet force field of an electromagnet can be turned off and on by using a battery, a magic bean, or a switch. The answer to the magnet force field of an electromagnet can be turned off and on by using a switch. If you move a magnet through a coil of wires, it generates an electric charge in a wire. This is called a generator. And that is what is being represented in the picture on the right. The magnets are moving through a coil of wires, which is generating electricity to light up the light bulb. How are they used? Every time you ring a doorbell or listen to music through speakers, you use an electromagnet. Electromagnets are used to make things move and turn things off and on. Experiment time, the best part of this presentation. We're going to be using magnets and iron filings to see the magnetic field lines. Now, you can find the instructions in the worksheet, in the directions, and the description of the video, but I would like to go over the general concept. First, you want to make sure that the students make their predictions on their worksheets. We're then going to go to the compass part of the experiment. What you want to do is use the compass to demonstrate how the poles of the compass and the poles of the magnet interact with each other. When you put a pole, or when you put a compass on the left side of the North Pole, the South Pole of the compass will be attracted to the North Pole of the magnet. This is due to opposites being attracted to each other. And as you move the compass around the magnet, you will see how the compass line will change in direction.
Hey everyone, this is Meryl and I'll be demoing the electromagnetics experiment. Before we actually start the experiment, we want to make sure that the students have a prediction first. So give enough time for these students to predict what will happen to the compass and to the iron filings when interacting with the magnet. Now, after we have done our predictions, let's get on to the experiment. So we want to take our magnet and have the South Pole facing the left side and the North Pole facing the right. We then want to take our compass, and as you can see here, the green end of this represents the north side, and we're just going to place it right to the left of this magnet. And as you can see in the worksheet, there are many compass bubbles, but we're only going to do some of them for this demonstration. So first, we have our compass, and as you can see, the North Pole, the South Pole of the magnet is attracting the north end of the compass. And this is all due to the concept of unlike poles attracting each other. And now we're going to move our magnet just a little bit over here. And again, you can see the north end of the compass being pulled towards the south pole of the magnet. Now, let's place it right above in the center. This time, the compass needle is exactly horizontal, but you can still see that the north end of the compass is still on the side of the south pole of the magnet, while the north or the south end of the compass is pointing towards the north pole of the magnet. Again, this is all due to opposite poles being attracted to each other. Let's move this a little bit. And now, because we're more towards of the north pole side of the magnet, the south end of the compass is pointing towards the north pole much more strongly than before. I'm going to move this compass one more time right down here. And again, the compass needle is exactly horizontal, and the south end of the compass needle is pointing towards the north pole of the magnet. And due to, again, attraction and repelling, you can see how the south pole of this magnet is pointing this way, yet the south pole of this compass needle is pointing this way. And this is just because it's attracted to the north pole of the magnet. And now we're on to our iron filings experiment. First thing you want to do is take your canister of iron filings and sprinkle just a little tiny bit onto your paper just to create a thin layer of iron filings. You want to spread it around evenly and want to pick this up. Let's move the magnet close and just place it right on top of the magnet. And as you can see, the iron filings move towards the magnetic fields just to outline them. And you can see that little circular pattern right down here and a little bit out here too. And that is our iron filings experiment.
So that's the end of this educational video.
I hope you learned a thing or two.
And I hope you enjoyed it. Thank you for watching with us.